test that we usually perform in this lab is the ESR, or otherwise known as the erythrocyte sedimentation rate. Okay, what this test is basically based on is that we are checking the ability of the red cells to settle at the bottom of the tube. The importance of that is that it gives a non-specific indication. I emphasize it is a non-specific test for the inflammatory process. Okay? Why? Because erythrocyte sedimentation rate, or ESR, is basically a check of how fast your red cells to settle at the bottom or how slow. And these are basically related to the presence of acute phase reactant proteins in the blood. What are those? These acute reactant proteins are elevated if a patient is having an inflammation. And if you have high number of these acute phase reactant proteins, as a result, whether you have inflammation or not, will break the zeta potential of the red cell. What is zeta potential? Is the negatively charged particles that surrounds each and every red cell, so that they will repel from each other under normal condition, which means that if you have high level of proteins in the blood as a result of inflammation, that negativity will be broken. Once it's broken, because proteins are said to be amphoteric substance. What does it mean? It has a positive and a negative charge. If you review your chemistry, if you have a positive and a negative sign, it will attract. But if you have a negatively charged particle around the red cell, that allows your red cell to repel and does not attract. Now, going back to the inflammation, that's why it is the test for inflammation. It's because during that process, acute phase reactant proteins, particularly the fibrinogen, which contains both a positive and a negative charge, if you have high level of fibrinogen, you are introducing large number of positive charge that breaks the negativity of the red cell, and therefore they attract each other. Once they attract each other, they will become heavier. Once they become heavier, they will settle fast. And that is the principle of this test. Okay? This tube is used for that purpose. Okay. Once we fill up, okay, this special tube containing the anticoagulant, sodium citrate, okay, it is a solution that prevents the blood to clot. Okay? So that your blood cells will be uniform and in a free, unclotted state. Okay? So it will not solidify, in other words. Okay? So therefore, once blood is filled up to this mark, mix well, and then we will allow this to settle at a specific time frame. We use this machine so that it will decrease the time of waiting, okay, from the conventional method of 1 hour. If we use this machine, it will only take you about 20 minutes to finish the whole test. Okay, so this machine is known as the Vesmatic, which means that you can run samples, 10 samples, 20 samples basically, all at the same time. Okay? So it's a very simple procedure. Once you have the sample, mix well, and then enter the barcode number or the identifier of the sample, for that particular patient, and once you enter them here, just press enter, and then it will show you which position of the tube here, or the location of the sample, and then you just press enter and it will do the test. Normally, the old method is we have to wait for an hour to wait for the red cells to settle at the bottom of the tube. But with this machine, it will only take you about 20 minutes and the test is finished. Once it's finished, you will see the end product like this. It is actually, so you can see red cells are settled at the bottom, and it is the plasma layer that we measure, which is a reflection of the value of ESR, and it is reported in millimeters per hour. So the higher the level of plasma, the higher the ESR. And so the lower the layer, or the smaller the layer of the plasma, corresponds to the ESR value, which is also lower. So basically, it's directly proportional. Okay? So that is the principle of this test. Very simple. Again, it is non-specific because there are other conditions that affect this test. Give you a brief overview of how a complete blood count is being analyzed. What is complete blood count? It is basically a test to measure all the different cellular counts, from white blood cells, red blood cells, and platelets. So in other words, we are counting the cells, okay, of your blood. Okay, so this is a state-of-the-art machine that is composed of 5 parts. One is the conveyor system, which allows your samples to be transported from one analyzer to the other. So this is one analyzer, this is second analyzer, and the third analyzer. It can run 100 samples per hour at the same time. So this is the sample. I'm just going to show you how they are being done. So it starts from the automatically taken up by the conveyor system. It scans the barcode over there. As you can see, there is a scanner. It will check the barcode. And once it's finished scanning the barcode, since we have 3 analyzers connected to each other, whichever analyzer is available will move that sample to the available analyzer. So now, this machine will take up the sample and in just about less than 5 minutes, it will take a portion of the blood sample and it will give you this product. So this is now a complete blood count that we are talking about earlier. So all these individual tests will be done in just a matter of less than 5 minutes. You have your white blood cells and RBC count, your hemoglobin, and other red blood cell indices, which you will understand in the future when you go to your high level of the course, and also the different count of your individual white blood cell population. Okay, so that's why it's called a complete blood count. Now, the final step is that this analyzer is intelligent enough because it will determine whether that sample is abnormal or normal. If it is normal, the result will be automatically released into the system so the doctors can see it. But if it is abnormal, it will automatically go to the next analyzer, which is the automatic blood smear preparation and staining. Okay, this is a machine that will selectively identify which sample requires a blood film or not. Once it is stained and once smear is done and stained, it will move to the next analyzer ultimately, and this is the final product. This is now the initial blood film morphology that is processed by what is known as the digital imaging technology, where that blood film that I have shown you earlier will be placed under a microscope that is built into this analyzer. It will capture a specific area in this blood film, and this is what it looks like, 100 times or 1,000 times magnified. And here you can see now the different cells of your blood. Okay, so before you can actually run a patient sample, it is very important that you do a quality control check of your machine. What it does is that you are using a commercially prepared blood sample with known values, okay? So that if you run this sample, okay, into your analyzer, it will measure, it will count the cells inside that are pre-measured, so that you have a low count, normal count, and high count. This contains specific values for each of the tests that we are going to measure, okay? So that these values must be able to you must be able to reach that value, okay, given by the manufacturer. And once you get that value, it will be plotted into each and every parameter on a daily basis, okay? This is to make sure that you are getting the right value, and so that your machine will achieve a precision quality, okay? Precision means that you are getting, or you are repeating the same value similar to each and every run of your analyzer, which means that your analyzer is working properly. In other words, your machine is of optimum quality and optimum reliable. You are getting optimum reliable results. Okay, so you are getting the level of confidence that your machine is working properly, so that you can run patient results. And therefore, whatever results you are getting at when you run patient sample is of high quality and reliability.